Hello everyone, welcome to the Code Syndicate. Today we will check arithmetic operations in Rust. Before we begin, in previous parts we missed the type conversion of floats to integers and integers to floats. So we will briefly check this and we will move to the today's topic. While changing from integer to float, it is simple and we do not need to care much about the conversion. For example, if we convert number 60 to float, it will become 60.0. Let's check this in code. Run the code. Look at the output. Here you can see it is 60. So basically while printing the number, the Rust automatically removes unnecessary digits after the decimal. So here 60.0 do not make sense as it is equals to 60. So here you are getting output 60 only. Next, when we convert a float to integer, it will completely remove the numbers or digits after the decimal. For example, if we take 72.75 and convert it to any of the integer type, it will become 72. Remember, this operation do not round off the number, instead it removes every digit after the decimal point. Let's check this in example. Change this type to F32 and this number to 72.75. Here change to int as let's say I16. Here you can have any integer type. For the sake of this video, I am taking a I16 type, but you can experiment with I32 or even U32 as well. Basically, what I mean to say is you can have any integer type, either signed or unsigned. Change this number int. Now run the code. Here you can see 72. So it removed this two digit, that is 7 and 5 after the decimal point to make this a integer. So as I said, this operation will not round off the number. So if you take this number and round off it, it will become 73. So that was for the type interchanging between float and integer. You can practice with other integer types and float types. Like you can experiment with I64 or U64 type and F64. Now let's get back to the today's topic. In Rust, we have these arithmetic operators. For the addition, we have this plus symbol in Rust. For the subtraction, we use minus symbol. For multiplication, we use star symbol. For division, we use plus. And for the modulus, we use percentage symbol. We'll check all the operators one by one. But before we start, here one thing is to be noted that we cannot exercise arithmetic operations between two different integer or float data types. For example, if we want to add a I8 integer with I16 integer, it is not possible in Rust. To do such operations, we need to convert either of one to match the data type of other integer. So here, which variable you want to convert depends on the situation and convenience of the programmer. Just make sure not to get some weird results which we discussed in the previous few videos. Now let's start arithmetic operations with addition. Let num I8 data type equals. Now let's add two numbers. Let's say 5 plus 2. Print the output. Run the code. Here you can see 7 as a output. Now this plus operator is used to add two numbers. Here you can see both the numbers are of same type, that is I8 type. Now what happens when we use two different data types? Now let's declare this as num1 and let it be 5. Num2, which will be I16 in this case, equals, let's say, 2. And instead of num, we can write run the code. Here, if you look at the terminal, you can see here expected I8 found I16. So first the Rust compiler checks the num1 type, which is I8 in our case, and then it checks this num2 type. So here, as the compiler is expecting I8, but it gets I16 type. So the compiler will not compile this operation. So in the second log, you can see no implementation for I8 plus I16. So basically it means you cannot add two different data types of integers in Rust. So when we come to these scenarios, what we can do is we can simply change this num2 to I8 or vice versa. Most recommended would be to change this I8 to I16 because we can have some numbers in I16 type which cannot be stored in I8. For example, if we have 300 instead of 2 in this I16 type, in this case, this I8 type can't store 300 and we will get some strange result. So what we will do is we'll change this I8 to I16. For this, let's wrap it up in the parentheses. So for this, we can say as I16. Run the code, and here you can see we have 7 in the output. So I hope you get the idea how this plus or addition operator works in Rust. You can take other numbers and practice with it. Now let's jump into subtraction. So similar to addition, we can do subtraction between two same integer type or float type. But in subtraction, we need to take care of negative numbers. Here, let's remove all the code and change this to I8 as well. Now let's do subtraction here. Inside the bracket, num1 minus num2. Run the code. As expected, we got 3. Now the thing is, if we take this U8 type, this also U8 type, and let's change this to 7. Now let's run the code. Here we get some error. If you check, attempt to compute 5, which is of type U8, minus 7, which is also a U8 type, which would overflow. So basically, what it means is, as the both the types cannot store negative number, so the result of this operation, which will be also a U8 type, cannot store negative number. So whenever you are dealing with unsigned numbers and you have to do subtraction, make sure you do not come across such scenarios where your operation will go overflow. That means your operation will result in a negative number. Now, to overcome this scenario, what you can do is convert both the numbers to I8 type. Now let's run the code, and you can see we get minus 2. If you are curious, we can have a floating point number as well. Num1 minus num2. Run the code. Now, if you look the result carefully, you can see there is a precision loss. As we discussed in the previous video, dealing with float is always tricky, or I can say it requires extra care. Extra care by the sense that it can always have precision loss. Here, if you see 5.28 minus 7.08, it should have 1.8, but in the result we are getting 1.7999. Of course there will be a negative sign. Now what about the division? Similar to addition and subtraction, we can also do division the same way. Here let's take I16 type. Now for the division we use plus. Run the code. Here we got 5. Now, if we closely observe, we are getting 5 instead of 5.5. So, what is happening here is, as both the numbers are I16 type, so the result of this operation will also be a I16 type. As I16 type cannot have or hold floating point numbers, so it will cancel out the parts after the decimal point. That is, it will remove or cancel out this zero point 0.5 and will result in 5 only. So this thing needs to be taken care of. So how to get the correct result here? Basically, what you can do is you have to change both the numbers to a floating point number. To do so, just create two different variables, that is num3, which will be a 32-bit float, equal. Now we can have this num1 as f32. Let num4, which will be the same data type, num2 as f32. Now change this to num3 and num4. Run the code and here you get 5.5. You can check division with taking other examples. Now let's move into the modulus. Now let's have a modulus operation. Let number I8 type, or you can have any type you want here. 5 modulus 2. If you do not know about modulus, this operation first divides this 5 by 2 and returns the remainder of this division. When you divide 5 by 2, you will get the remainder 1. This remainder will be stored in this num variable. Here it is. Here you can have floats as well. Like let's say you have, if you look at the result, you can see 1.1999, or you can say this is as 1.2. Now let's check the code. Here we have 5.2 modulus 2. If you take 1 here, you can have 1 in the output. So what is happening here is, in first case we are dividing 5.2 by 2.0, or we can say by 2. Now when we do this division 0.2, now we divide 5 two times, it will have 4, and 5 minus 4 is 1.2 as the remainder, and we get this 1.2 in the console as the output. If you can see this, you can take it as 1.2. And in second scenario, we are dividing 5.2 by 2.1. Now let's try to divide 5.2 by 2.1. If we multiply 2.1 by 2 times, we'll get 4.2, and the remainder will be 1.0, which we get here. That is it for today. I tried to explain briefly about all the arithmetic operators and operations in Rust. If you have any doubt, let me know in the comment section. I will try my best to answer you out. If you like the video, please click the like button and subscribe to my channel. Thanks for watching, and I will see you in the next video.